The next part is about hence questions in cubic equations. Now hence questions, right, they are usually part 2 questions, so you have to use your answers from part 1. So whenever you see the word hence, don't think of like trying to redo the entire question from scratch. You just have to find some way to use your answer from part 1. So if we use the same polynomial as from the previous equation, when we solve it, we will get x equals to minus 1 or x equals to minus 3.56 or 0.562. So to solve hence questions, we must ensure that the coefficients and constants are the same. So what are the coefficients in this question? So there's an invisible 1 here. So we have 1, 4, and then another invisible 1. And our constant is minus 2. The first example, we have solved bracket x minus 2 cubed plus 4 bracket x minus 2 square plus x minus 4 equals to 0. Now there's like something that you can kind of see in this example, right, is that all of the coefficients in front of the brackets, like for example invisible 1, and then 4, and then another invisible 1, and then minus 4, okay, aside from the constant, right, the rest are like roughly the same as the polynomial that's given, like in this part here, 141 and minus 2. Then you can kind of identify that this will be some sort of manipulation from your part 1 answer. You can kind of see that the x is replaced by x minus 2 inside the brackets. Now as for why the constant is minus 4 instead of minus 2, once you write out your polynomial by with x replaced by x equals to 2, you will see that this part becomes x equals to minus 4. That's how you get your new minus 4 constant. But when you write it out, like in this equation, right, you will still see that you still have your minus 2 from the original constant. So now that you know that all the x is replaced by x minus 2, then you will just let your answers equate to x minus 2 instead of x. Because when you solve, right, you're solving for x equals to y, x equals to y, x equals to y. But since now your x is replaced by x minus 2, instead of x equals to what, it will be x minus 2 equals to what. So x minus 2 equals to minus 1, x minus 2 equals to minus 3.56, and x minus 2 equals to 0.562. Then you carry the 2 over, it will become minus 1 plus 2, which gives you 1. Then do the same for the rest, just carry the 2 over, and then you will get your new answers. Now for example 2, it might be a little bit harder to spot, but you can kind of see or like infer that 8 is a perfect cube and then 16 is a perfect square. So when you see these kind of special numbers, just try and keep in mind what the new replacement for your x may be. So if we think back to the original coefficients, they were 1, 4, 1, and then the constant is minus 2, right? You notice that you still have your constant of minus 2 over here. You still have your constant of minus 2. And then this x becomes 2y. So once you see a direct comparison of x becoming 2y, there's a chance that this replacement will be x equals to 2y. And now you can verify with your other numbers in this polynomial, other terms. So you want your coefficient for this one to be 4, right? So you factorize out of 4, and then what's left will be 4y squared. And then you realize that 4y squared, you can bring the square out, which becomes 4 bracket 2y whole thing square. And now it's even more obvious that your x is being replaced by 2y. And for this one, it will just be 2y whole thing cube. So yeah, now you can see your replacement is x replaced by 2y. So once again, you will let 2y equals to your original answers instead of x equals to your original answers. So 2y equals to minus 1, or 2y equals to minus 3.56 or 0.562. And then from here, you divide by 2 on both sides. So your new y is minus half minus 3.56 over 2, which you can calculate for. and 0.562 over 2. So that's your new y answers. That's solving for y. Okay, next, the last one. Solving for 2x cubed plus x squared plus 4x plus 1. So for this example, we are trying to make our given equation look somewhat similar to the equation that we had at the start in terms of the coefficients and the constant being the same. To solve this new equation, we must keep our constant the same as the original equation. So minus 2 will still have to be our constant. So how do you get minus 2, which is this coefficient? We can divide all by x cubed. We will get this equation. And then once we rearrange it with the x cubed term being at the start, followed by the x squared, the x and the constant, then we will get this. And it's starting to get a bit more similar to our original equation, right? So then we factorize the 4 out here so that the coefficient will be 4. Then you have your original coefficients again, 1, 4, 1, and minus 2. And now the replacement will be seen very clearly because it's just whatever's inside the brackets. So now you know that x is replaced by 1 over x. So once again, you will let your answers equate to 1 over x. 1 over x equals to minus 1. Then we will know x equals to 1 over minus 1 equals to minus 1. Or 1 over x equals to minus 3.56. And you know x equals to 1 over minus 3.56. And likewise for 0.562. Okay, now let's move on to an example. This example will first be looking back to the inspection method, to revise the inspection method again. So we have the function of x cubed plus ax plus b, and then we are told that it's exactly divisible by x plus 5. So once again, when you see exactly divisible, you must think of factor theorem. And then given that fx leaves a remainder of 24 when divided by x minus 3. So this one, you will think of remainder theorem. So we have to find the value of a and of b. Okay, so we'll just use our factor theorem. So we let x plus 5 equals to 0. That's how we get x equals to minus 5. And then we know to sub x equals to minus 5 into a polynomial, then equate it to 0. So that's how the factor theorem works, right? Then we'll get our first equation. Then by remainder theorem, from the divisor that we got, equate it to 0. X equals to 3. So we know to sub x equals to 3. And then equate it to our remainder of 24. That's how we use the remainder theorem. And then we'll get our second equation. So solving simultaneously, then you will get a equals to minus 16 and b equals to 45. Now the second part of the question, we are showing necessary working for the number of real roots of the equation. So if we are finding the number of real roots, the question is asking us to factorize the polynomial so we know how many roots are there. So if we go by inspection, can look here first. We know that our first bracket will be x plus 5 because they told us that there's a factor of x plus 5. So our first bracket, x plus 5, and then your remaining quadratic can leave your unknowns as b and c. Direct comparison for your highest power of x first, the x cubed, you will see that in front the coefficient is just 1. And on the right hand side, it's also just x cubed already. So the first one, technically you don't even need to add like unknown of a, for example, because you can just tell that it's 1. Like a will be equals to 1. So now we compare the lowest power to get c. So how do we get c on the right hand side? We'll use 5 times c. And then on the left hand side, your constant is 45. So you can let 45 equals to 5c, c equals to 9. And to get b, We can sub any random value of x and then solve for b, or we can also do what we did previously, which is to compare coefficients for x. So on the left hand side, the coefficient of x is minus 16. And then on the right hand side, how do you get your term for x? It will be 5 times bx plus cx. And then you know c equals to 9, so you can sub that in. So minus 16 will be equals to 5b plus 9. And then you shift it over, minus 25 equals to 5b, b equals to minus 5. That's how you get b. So you have, subbing back your values of b and c, you can get your final quadratic bracket. And then you want to further factorize this quadratic bracket if you can, right? But then when you key into your calculator, find your roots, you'll see that there's no solution. So to show that there's no solutions, you cannot just state that there's no solutions. You have to use discriminant and show that the discriminant is less than 0 to prove that there is no solutions to this. So just for our quadratic factor, we use the discriminant v squared minus 4ac. This is the discriminant formula. And then we have to show that it is less than 0. Therefore, we'll state that there is only one root, which is x equals to minus 5 from this factor. Second example, given that fx equals to 6x cubed plus 3x squared minus 22x plus 6, and this is a factor, find the value of a. Now, we can find the value of a by doing direct comparisons between our given function and the function that we eventually come up with when we do expansion. So what do I mean by that? Let's go step by step. First step, by inspection, we'll get our 2x minus 3. So how does that happen? Firstly, we can write out our polynomial equals to our known factor given in the question. And now since we have, this is already our quadratic factor. So what's left is our linear factor. So we can leave the unknown coefficients as b and c. Now to get b and c, we can compare the coefficient of the highest power, x term, x cubed, and the lowest power x term, which is our constant, 6. On the left hand side, the coefficient of x cubed is 6. The right hand side, it will be 3x squared times bx, so 3b. That's how we get b equals to 2. Now for our constant, on the left hand side is 6, and on the right hand side, it is minus 2 times c. So we can get minus 3. So subbing our b and c back in, we will know that our linear factor is 2x minus 3. And that's how we arrive here. And then we'll expand everything on the right hand side, and we'll group the x squared terms and our constant term together so that we can show our coefficients very clearly and our constant. So this is our entire constant, and then this is our coefficient of x squared. So comparing x squared, we will get 2a minus 9 equals to 3. So we're comparing between this one and from our given polynomial, this 3. That's how you get a equals to 6. Okay, now moving on to the next example. It's given that our function is 2x cubed plus ax squared plus x plus b, where a and b are constants. Find the value of a and of b for which 2x squared plus x minus 1 is a factor of fx. So if you recall, you can only use factor theorem and remainder theorem using linear factors. So this is a quadratic factor, right? Means we need to further factorize it, end up with these two brackets. From then on, then we can use the factor theorem. This equals to 0, then x equals to half. And then we will sub x equals to half into our polynomial and then equate it to 0. That's how we get our first equation. Then our second equation, we'll use our second factor. So x plus 1 equals to 0, x equals to minus 1. Sub minus 1 into your equation, let it equate to 0. That's how you get your second equation. Then you solve simultaneously. Then you get a equals to 5, b equals to minus 2. Now part 2, you have to solve the equation. So solve, if you recall, you have to show your final answer has to be x equals to something. Now we can use either long division or the inspection method. Either way will be quite fast for this solving because we already have our quadratic factor. Now we just need our linear factor. For example, let's try and use long division. And then we have our divisor 2x squared plus x minus 1. Then we just know first one will be x because we want to eliminate 2x cubed. Then you bring down everything, bracket and your negative sign, 4x squared plus 2x minus 2. Then you eliminate 4x squared. Yep, and then you get a remainder of 0. So now it's fully factorized. And then x plus 2 is your linear factor. You will end up with this, which you can further factorize your quadratic bracket into these two brackets. So you'll end up with 3 factors. Then let it all equate to 0, 2. So you have these 3 values of x. Now part 3. This is what we call the hence questions that we just went through the concept of. What we have to first think about is that when we get an unknown equation, we'll try to compare it with the original equation and then form back the original coefficients. So in the original equation, coefficients are 2, 5, 1, and then our constant is minus 2. After subbing in our values of a and b from part 1 into our equation, we will get this. And what do we do now? We'll factorize out the coefficients from our original equation. So our 2, 5, 1, and minus 2. Because what is left in the bracket will tell us what we need to replace x with. Please note that there's an error and this cube is supposed to be inside the bracket. You can see that we factorized out 2, 5, an imaginary 1, and a minus 2. But everything inside the bracket is still different. How can we make everything inside the bracket the same thing? We can re-represent 1 over 8x cubed into 1 over 2 cubed x cubed. And you notice everything in this is cubed. So you can just take out the cube. So inside the bracket, you will have half x and then whole thing cubed. Same for 1/4 x squared. 1/4 x squared can also be represented as 1 over 2 square x squared. Since everything is being squared, you can take the square out and it will become half x whole thing squared. That's how we arrive here. Now you see that everything inside the bracket is half x, and half x. So you know that we are replacing x with half x. That's why finally, you will let half x equals to the values that you got from part 2. And then eventually you get your final answers, x equals to 1, minus 2, and minus 4.